Okay, today we're going to be working with Unit 4. Our main focus on Unit 4 will be vectors. It's particularly important that we get towards vector-valued functions, which will be the third lesson in this series. Vector-valued functions is a topic which is a prerequisite for those who are going to be doing Calc BC next year. In Calc BC, you have to be able to find the derivative of a vector-valued function. So this part of the unit is preparing you for that. We have a little bit of basic understanding of what a vector is with 2 lessons on vectors. Vectors lesson 8, part 1 and 2. And then vector 9 is vector-valued functions, and then we'll do a little bit with matrices, and then we'll have our end of unit test. So today we're introducing what is a vector and our ability to identify the characteristics of a vector. So a vector is a quantity which has a particular direction. So for instance, to give you a best example, we can talk about distance. No, the best example would be speed. If you drove from here to Motor City, we could describe your speed. And your speed would be how fast you travel. Now let's say you drive down Sheikh Zayed Road and you go up Sukim, and then you move your way across and you eventually get yourself over to Motor City. Maybe you're going at 60 kilometers average speed the whole way. But the problem with that is you are going not in a direct line. If you're calculating what your velocity is, you're going to be how far away Motor City is from this location directly, divided by the time it took you to get there. Whereas your speed is how far you traveled, divided by how long it took you to get there. So your speed would be much faster than your velocity, because your velocity has to have a specific direction from here to Motor City, whereas your speed doesn't. It's your speed along the path. So the difference between those two quantities is one of them has a specific direction. The other one just has magnitude. So one of the things we want to do is we want to calculate the magnitude of a vector when given it, and then we're looking at some mathematical operations with vectors. We'll look at the scalar multiplication, and we'll look at addition. So when it comes to vectors and matrices, which this topic looks at, addition is kind of the same as what you're experiencing. There is no subtraction in mathematics. You're just adding a negative. There is no division. You're just multiplying by a fraction. So you don't divide by 2, you multiply by a half. So in mathematics, we need to know how to multiply, and we need to know how to add. When it comes with vectors, multiplication, and with matrices, there's more than one type of multiplication. There is more than one type of multiplication. You know, in math, we have 2 symbols for multiplication. Sometimes we use a dot, and sometimes we use a cross. They're actually different when it comes to vectors and matrices. So those 2 types of multiplication produce a different result when it comes to this topic. Whereas those type of multiplications, when with numbers and with algebra, it's the same. So we can use both symbols, interchange them. As you'll see in this topic, no more. We cannot. All right, so we're going to kick off with a bit of a do now. Pause the video at home, for those following at home. Have a go at this question, and then we'll discuss it. Okay, so to solve a problem like this one, we want to do a little bit of a sketch. So we have some axes like this. This is our x-axis, this is our y-axis. We have a circle centered at the origin, and then we're given a point P. Point P, we're told, is at 9, 12. And we're asked to find the radius here. So we can see that we're used to working with a bit of coordinate geometry now, that this length of this side is going to be 12, the length of this side is going to be 9. So Pythagoras' theorem tells us that r is going to be the square root of 9 squared plus 12 squared. calculator. And I think the answer is 15.
Yeah.
Yeah. How can we find the angle theta here? Well, the angle theta is going to be arctangent of opposite over adjacent, and the opposite is 12, and the adjacent is 9. Put that into our calculator. Let's have it, I'll pull up my calculator for that one. So I want the arctangent of 12 over 9. And we get 0.927 radians. We will work a little bit with degrees in this unit. Often when you're doing displacement and movements and bearings, we do use degrees for that type of a topic in mathematics. So we just switch over into degrees, press Control Enter, 53.1. And that's in degrees. If you're writing in degrees, you have to use the degree symbol. If you don't have a symbol for, a unit symbol for an angle, then it's always assumed to be in radians. So then what we need to do is we need to write a general formula for the point P on the circle with radius r and angle theta. And you can draw back to your understanding of the unit circle and what we've done on this course. So this length here, the opposite, is going to be, sorry, let's do the adjacent. The adjacent is going to be r cosine theta. And the opposite is going to be r sine theta. Think about the unit circle. We've done problems like this one earlier in the course. So this is P equals, so here's question 3, here's question 2, here's question 1. So this links entirely into today's lesson, what today's lesson is about. We are working with lines like this one. So we could describe the line from the origin to P as a vector. So this is an example of a vector. This would be the direction vector OP. So this would be the direction vector OP. That's sort of a line. That's what a vector looks like. So just moving on, a vector is a quantity with magnitude and direction. So you have to have magnitude. That's your R. You have to have direction. That's your theta. So R and theta give the direction and the magnitude of the vector. So we write vectors typically in bold. You can't write bold by hand, but you can do it with, so we put a line over it, and the direction of the line is important. You saw then when I'm doing the vector OP, I go OP and you put a line in this direction. The vector OP is different from the vector PO. The vector PO goes in the opposite direction. It would be the minus sign. You add a minus sign and you can go in the other direction. So we have a few different notations. You'll see it written like this. You'll see it written like this. This is, so here is a row vector. This one is a column vector. You'll also see different different symbols used. So often for vectors, we'll use these for our brackets. The calculator is going to use square brackets for it, and you have to stick with a particular format. So we're showing here an example of a vector. This is the vector V. The vector V is 512. The vector V is 512. That means we are, I don't think this one is 512. 1, 2, 3, 4. Yeah. So this, what's shown here is not the vector. What shows here is not the vector V. This is just an example picture of a vector.
Oh.
Yeah.
But what if the scale is V? I mean, like scale of 1 box for y-axis is like 3.
So if this is the vector U, this one here is
6, 4.
is 7, 4.
Oh.
Try and avoid doing that line. You'll find it really difficult. There is no line across in the middle, but you saw me just do it maybe. I don't know if you caught it. When you're trying to write one number above another, it's so tempting to draw that line across. You're going to do it. You're going to do it. Literally, the first time I'd done vectors this year, I did the line. The very first vector I wrote. So here's an example of a vector. In this question, we want to find the magnitude of the vector. So the absolute value of a vector is its magnitude. So that means we are finding the length of this vector. So having a go with vector v, the magnitude of this is going to be given in the same way that we just did. So we need 5 squared plus 12 squared. Have a go with that on your calculator. I'm just going to try it here myself. 5 squared plus 12 squared. Control Enter. 13. So this is equal to 13. That would give us the magnitude of vector v. Right, there's one for you to have a go at. Find the magnitude of vector v. Again, this is not the vector shown. This picture here, I don't know why I've got this picture here, is not the vector v and it's not the vector u. Let me delete that one. What was that? Oh no.
Sir, are we going to teach APPC next year?
No.
Why? But are you going to do it if you have a chance? Like if school allows you to do it? Are you going to do it?
If I asked to do it, they would let me.
Actually?
Yes. Of course.
What other classes do you teach pre-com? IB? Advanced.
Yeah. Okay, so for this first one, we need to find the magnitude of v, which is equal to -4 squared plus 8 squared. Let's do this on the calculator. Watch me along on the calculator. I'll show you 2 ways to do it. So we can just use the formula. Need the bracket for the negative. -4 close bracket squared plus 8 squared. And we get 4√5. This is the exact 4√5. We can also use the menu. So here in the watch this bit along. Here on the menu, you can find vectors and matrices. Most of the operations we'll do are under C, but for the magnitude, we want the norm. We want the norm of the vector. So then, pull up your vector template here. Sorry, your templates button next to the 9. Pull up the templates button, and we're going to choose this particular type of a template. We can put in our vector, -4, 8, and then we press enter. And this will give you the absolute value of the vector. Secondly, for example 2, we need to find the components of u. So the components of vector u are equal to r cosine theta, r sine theta. This is the formula for finding the components. So in this particular case, we've got, r cosine theta, or the argument, and then the magnitude of the vector times the sine theta.
So I have one question.
Yeah.
For the first example, is it just 10? 16 plus 64? Oh, never mind. I'll stop it.
So for this one, we are going to need 15 sine, cosine, 15 cosine theta, 60 degrees, 15 sine, 60 degrees. You pull up the calculator on that one. Make sure that I am in degrees. If I want to just do this as a vector, you can find the vector button here. Sorry, let me do it as using the templates. I'll pull up this one. And here I want 15 cosine 60 over 15 sine 60. And I get these two values. If I wish to have them as decimals, Control Enter, 7.5 and 13.0. There's our answers. Okay, have a go for yourself with this one. Find the components of the vector. Try and use your calculator for this one.
No, well, for the grades.
Okay, so let's have a look at this. I'm just going to press here, get my vectors up. I want 6 cosine 160. And here I'm going to have 6 sine 160. Obviously, we're expecting the x component to be negative and the y component to be positive. Let's have a look. Control Enter. Yeah. So we get minus 5.64 and 2.05. Okay, so next we are looking at multiplication. Our first multiplication is scalar multiplication. Scalar multiplication is quite easy. So there are two types of numbers. There are vectors, which have magnitude and direction, and then there are scalars. Scalars only have magnitude. They only have magnitude. They have no direction. Often we use lambda for our constants. You know how in math we often like to use certain variables for specific reasons. We tend to use theta for an angle. So when it comes to vectors, we tend to use lambda for a scalar. So if we're multiplying a vector by a scalar, we simply multiply each component by that scalar. So as this example is shown here, in example 4, if we have to multiply by a scalar, let's have a go at drawing them. So the vector A here is 3 minus 2. So I can draw it anywhere. A vector can be drawn anywhere on your coordinate axes. And in this one we need to, I'm going to start here, and it looks like this. This is the vector A. 3 minus 2. This is the vector A.
Is that negative 3, negative 2?
This is 3, negative 2. 3 across, 2 down. Doesn't matter where in the coordinate axes I draw it. If I draw it here, this is also the vector, I have to show direction. This is also the vector A.
Oh,
This is also the vector A. It can be placed anywhere. It doesn't have a location. It's a movement. It's a movement from, yeah, it's a movement from one location to another. but it doesn't have any particular point in space it has to be.
I learned it, yeah.
Yeah. So if we multiply that by a scalar, the new vector would be 6, negative 4. So the new vector, let's start it off here. It would go 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 4. So this is the vector 2a. This is the vector 2a. This is how it would look. Notice it's going to be parallel to the vector a. Multiplying by a scalar is not going to change the direction it's flowing in. It's just going to change the magnitude. It's not going to change the angle. If you look at this vector, look how they're parallel. No matter where I place the vector 2a, it's going to be parallel to all of the vector a's. That's an important idea about vectors. All right, so have a go at sketching the vector b, and then calculate what is negative 2b, and sketch that. Tell me what you see. Okay, so the vector b is 3 minus 2. So let me start off here in the top corner, 3 minus 2. This is the vector b. Multiplying by the scalar, we are going to get minus 6, comma 4. So if we sketch that one now, I'm going to start here. We go 1, 2, 3, 4, 5. Sorry, 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. What do we notice about minus 2b?
It's moving in the opposite direction.
It's moving in the opposite direction, but notice how they're still parallel. Notice how they're still parallel. So when you multiply by a negative scalar, you will change the direction of the vector. You will change the direction of the vector. When we multiply by a scalar, we don't change the angle, we can just change the magnitude. And we can go in the opposite direction. Vector addition. Vector addition is pretty easy. You add two vectors together, you add the x components, you add the y components.
So is that a typo, A1 plus A1?
Yes, there's a typo there.
A1 plus A2, right?
Yes, there's a typo there, thanks. So fairly straightforward. Let's have a go at doing this problem, both algebraically and geometrically. So if we're adding these two vectors together, we've got 3, negative 2, plus 2, 5. This is going to give us 5, 3. This is our result algebraically. Let's have a go at doing it geometrically. So a lot of this is very visual, very important. So I need to start off by drawing the vector, the first vector, we'll call that one v. So I'm going to start here at the origin, and we would go 1, 2, 3, and then 2 down. So here's our first vector. V plus u. So here is the vector v, and then we need to add the vector u. Vector u is 2, and then 1, 2, 3. So it's going to be like this. This is the vector u, this is the vector v. Sorry, right. V. And u. So this vector here, w, the resultant, that would be geometrically, not even going to calculate, it would be this. It would be this. This would be the vector w. Now let me calculate that. That has gone 1, 2, 3, 4, 5 across, and 1, 2, 3 up, which matches our result that we see here. So visually, it's really interesting, better to see. If you're adding vectors together, you draw one, and then you add top to tail of the next one. You draw the next one, there's another one, you add top to tail on that one, and the resultant goes from the first tail to the final top. And we can see how it looks like that. Okay, we're ready for our exit ticket today. Let's see if you've learned what you need to learn. Here are the vectors u and v. Have a go at finding the magnitude of u, and have a go at finding 2u minus 3v. Make sure you've understood the essential from today by being able to complete this question. Going to run through this problem. We need to do it with a calculator, without a calculator. So I'll run through it first without a calculator, and then I'll check my answers with the calculator. Use this approach when working with the classwork and the homework activities yourself. So we need to find the magnitude of the vector u. That means we need 4 squared plus 2 squared. That means we need 16 plus 4, root 20, which is 2 root 5, I believe. Let's try B. We need 2, I'm just going to write that, sorry. 2, 4, 2, minus 3, minus 3, 5. That's going to give me 8, 2. That's going to give me 9 minus 15.
Well, why is it 8, 2?
8, 4.
8,
Oh, wait, 4. 4, thanks. I always like it when people catch me making a mistake during the video. Much worse when they tell me after we've pressed stop.
So for B, I got something like this.
Let me get through to the problem we can compare. And then I'll look at your answers. Alright, so this one's going to be 17, and this one is going to be minus 11. Here is our answers. Let us now check with the calculator, using some calculator routines. So what I can do is I can pull up my template here, like this. I can enter in my vector 2, and I can press Control, store. I'm going to store that in U. Press Enter. Pull up my template button again, and take the other one, -3 and 5. I'm going to press Control, store, and stick that in V. Okay, so then menu, vectors, norms, pull up the norm. I want the norm of U. 2 root 5. I got that one right. And we want 2u minus 3v. Notice how they're in bold here, it knows. 17 minus 11. Did I get it wrong? No, I didn't. I just didn't remember what I got earlier. 17 minus 11. Okay, that is it for today. Have a go with the classwork activities. Use your calculator to check after you've done, and then have a go with the homework exercises.